Bismillahirrahmanirrahim. Dear students, hope you are well and doing great. The video on this topic, test for detection of carbohydrates in alkaline and acidic medium, contain instructive and educational content that is both shareable and easy to retain. So let's start. Content. Following are the topics which I will try my best to explain during my presentation as much as possible for me. First of all, Mehwish test, then Benedict test, then Fehling test, Tollen test, Seliwanoff test, Barfoed test, Osazone test, Hydrolysis test, iodine test, Cobalt, chloride test. First of all, I will explain the Mehwish test. Mehwish test is a type of test for the detection of carbohydrate which apply to all types of carbohydrate. Either it might belong to monosaccharide group, disaccharide group, or polysaccharide group. In case of monosaccharides, it will give a positive test quickly. In case of disaccharide and polysaccharides, the reaction will proceed, but the extent or severity of reaction is slow as compared to monosaccharide case. The Mehwish reagent dehydrates pentose to form furfural, then dehydrates hexose to form 5-hydroxyfurfural. The furfural further reacts with naphthol present in the test reagent to produce a purple product. 1 ml test solution plus 2 drop naphthol mix well. Add concentrated H2SO4 down the side of the tube to form the ring at the interference of 2 layers. As we add H2SO4 downside of tube, a ring is formed at the junction of 2 layers. Following are the chemical reactions which undergoes during Mehwish test. First of all, pentose in the presence of H2SO4 converted into furfural. Then furfural in the presence of alpha naphthol form purple ring. Then hexose in the presence of H2SO4 form 5-hydroxymethylfurfural. Then in the presence of alpha naphthol it form purple ring at the junction of 2 layers. Result. Appearance of reddish violet or purple color ring at the junction of 2 liquids is observed in a positive Mehwish test. As you can see in this pictorial representation that a purplish ring is formed at the junction of 2 layers, which indicates that the test is positive. Any type of carbohydrate or carbohydrate belongs to any group might be present in that solution. Then Benedict test. For the Benedict test, take 5 ml of Benedict reagent, add 8 drops of carbohydrate solution, boil over a flame or in a boiling water bath for 2 minutes. Let the solution cool down. In case of positive reaction, a reddish brick color or orangish color is formed in the test tube. In case of negative test, you can see that a bluish color is formed. Following are the chemical reactions which occurs during the Benedict test. First of all, preparation of Benedict reagent. For the preparation of Benedict reaction, copper sulfate pentahydrate plus sodium carbonate plus sodium citrate react to form Benedict reagent. For the Benedict test reaction, cupric ions plus aldehydrates form carboxylic acid plus brick red precipitates are formed, as you can see in the previous picture. The color of precipitates are given. The colors which are formed during the reaction might be yellow, orange, brick red, or greenish precipitates. If the solution is blue, then the test is negative. Greenish or yellowish pipettes means trace of reducing sugar are present. Orange red pipettes mean a moderate. The reaction is at moderate condition. And if brick red pipettes are formed, means that large amount of reducing sugar is present in the solution. Fehling test. The test is used to differentiate between reducing and non-reducing sugar. A reducing sugar is the one which reacts with Fehling solution to form precipitate of orange to red in alkaline solution. Positive test is detected by reduction of deep blue solution of cupric to a red precipitate of insoluble cupric oxide. Take 1 ml of sample in dry test tube. Take 1 ml of distilled water in another tube as a control. Add 1 ml of filling reagent A and B to all the tubes. Keep in boiling water bath. Look for the development of red precipitates. Filling reagent. Filling reagent is a reagent which is used in the filling test. 2 solutions are required. Filling A using 7 gram of CuSO4 5H2O dissolved in distilled water containing 2 drops of dilute sulfuric acid. Filling B is the one using 35 gram of potassium tartrate and 12 gram of NaOH in 100 ml of distilled water. Result: positive Fehling test. In case of positive Fehling test, reddish brown pipettes are formed, which indicate that glucose, fructose, and lactose might be present in the solution. Negative Fehling test, no red pipettes are formed, which indicates that sucrose and starch is present in the solution. Tollen test. This test is given by reducing sugar. Carbohydrates react with Tollen reagent form a silver mirror on the inner wall of the test tube. Tollen test is also known as silver mirror test. The formation of silver mirror in the inner wall of test tube indicate or confirm the presence of reducing sugar. Silver ions are reduced to metallic silver. These are the chemical reactions which undergoes during Tollen test. Seliwanoff test. For the Seliwanoff test, take 3 ml of Seliwanoff reagent, add 1 ml of fructose, boil for 30 seconds only, cool the solution. Result: a cherry color is observed in a positive reaction. In case of positive reaction, a cherry color is formed. Barfoed test. Take 1 ml of sample in a dry test tube. Take 1 ml of distilled water in another test tube as control. Add 2 ml of Barfoed reagent to all the tubes. Keep in boiling water bath. Look for the development of brick red precipitates. Note the time taken to develop the color. You can note down the time which requires the formation of brick red precipitates. Reagent for Barfoed test. Test solution contains 5% glucose, 5% sucrose, 5% maltose, 5% lactose, and 5% starch. Barfoed reagent. Cupric acetate in 1% acetic acid. Then water bath, dry test tubes, and pipettes. Result: 3 ml of Barfoed reagent is added. The solution is then heated in a boiling water bath for 3 minutes. A positive test is indicated by the formation of a reddish pipette within 3 minutes. In this pictorial representation, you can see that solution in case of absence of carbohydrate, solution remains blue. If carbohydrate is present, then red precipitate is formed. If precipitates form faster, it indicates that monosaccharide is present. If precipitate formation is slow, then it indicates that disaccharide is present in the solution. Osazone test. Osazones are formed when the sugar reacts with the compound known as phenylhydrazine at boiling point. These sugars are reducing ones which have either a free aldehyde or ketone group to react with phenylhydrazine. Pipette 1 ml of the phenylhydrazine mixture to the test tube. Add 5 ml of the test tube. Shake vigorously to ensure complete solution. Stopper the mouth of the test tube loosely with cotton. Place the tube immediately in a boiling water bath. Record the time. Observe the tube. If a precipitate is formed, then cool the tube. You can see the microscopic observation. Hydrolysis test. Add 2 drops of HCl and 1 drop of thiamol blue to 5 ml of sucrose solution. The development of pink color indicates that the solution is acidic. Divide it into 2 equal parts. Boil one portion for about 1 minute and then cool it under water. Neutralize both portions by adding 2% sodium carbonate drop by drop. Hydrolysis test for sucrose. Formation of blue color indicates neutralized. Perform Benedict and Seliwanoff test with the boiled portion. Boiled portion give positive test with Benedict reagent, but unboiled test does not react Benedict solution. Iodine test. Addition of few drops of iodine solution of starch given a dark blue color. As you can see that in this picture, a dark blue color indicates the test is positive or iodine is present in the solution. Cobalt chloride test. It is used for the identification of glucose and fructose. If glucose is present, then it will give greenish blue color. If fructose is present, then it will give purple color. Test sample plus 3 ml, add 2 ml of COCl2 solution, boil the solution and cool the solution after boiling, and then add few drops of 4% NaOH solution. Greenish blue color appear. If the greenish blue color appear in the test tube, it indicates that the glucose is present in that solution. If purplish color is formed, it indicates that fructose present in the solution. If upper layer contain greenish blue and the lower layer contain purplish color, it indicates that both glucose and fructose are present in the solution. I try my best to explain my topic, but if anyone have any query in my presentation, you can freely ask. Thank you so much for your time and your patience listening.